Okay, so the next set of questions is just sort of seeing if you know how to use your laws of logs in different ways. And so our first statement here says that if the log of f equals 3 and the log of u equals 2, then find, in the first case, the log of fu all cubed. Okay, so we know that if we multiply two terms together, we can write this as two separate logs. So maybe pause the video and see where you get to with this set of questions. Okay, we're back in. So here is one way to do this. We could say this is the log of f plus the log of u, and that's kind of all in brackets being cubed. Now notice that I didn't use the power law here. I didn't move the 3 in front, and the reason for that is it's not the f or the u that's being cubed here. It's actually the entire expression. So that's not really a power of those terms there. Okay, so we now know the log of f apparently from above is 3. So it says right here that the log of f is 3. So that's really going to be 3. And then we're told the log of u is 2. So that's just 2. And now we know 3 plus 2 is 5. So we really have 5 to the power of 3. And 5 to the power of 3 is 5 times 5 times 5, which is 125. For the next question, we know that, once again, we could separate the two logs. So we would get the log of f squared, and then we'd be adding that to the log of u. And we could use the power law now, so that's really going to be 2, lots of beeping noises, log f plus the log of u. And from above, we were told the log of f is 3. So this statement here would be 2 multiplied by 3. And now we're just adding the log of u, and the log of u is 2. So 2 times 3 is 6, plus 2. And then 6 plus 2 would be 8. Okay, so our next question here, got a couple more to go. Says solve for x in the following statement. So once again, these questions are designed to see if you can use various laws of logs and your understanding of logs to isolate a variable in this case. Now this looks pretty daunting. You got lots of log terms here, and you've got a constant term on the far side. So I'm already thinking I'm going to have to at some point change this to exponential form at some point. But let's see if we can work with the logs and rearrange a bit of that first. So once again, see if you can pause the video and work through those. Okay, so we notice we got multiple brackets here, so I might just start with the inner bracket being log base 3 of 27, and that's really saying 3 to what power is 27, which of course is 3. So maybe I could rewrite this as log base 2 of log base x of 3. And that's supposed to all equal -1. Okay. So right now I don't know what I can do with log base x of 3. It's not really clear what that would equal. But what I could do is say that the log, I'll show you maybe on a sort of a side question here. If you had log base 2 of, let's say a, equaled -1, you could say that's really 2 to the power of -1 equals a. So we could think of this part right here as being the a, if that makes sense. So we could say 2 to the power of -1 should equal that part, that part we called a there, which would be log base x of 3. So we know to the -1, we reciprocate that, so that's 1/2, and that equals log base x of 3. And so now if we change that to exponential form, now the base is x. So this would be x to the power of 1/2 is equal to 3. And a fractional power like that is actually a root. But there's a couple ways to do this. So it could be like the square root of x equals 3. So you could square both sides, and so that would give us x equals 9. Or an alternate way here would be to just square both sides right now. If you have x to the half equals 3, why not just square that side to give you x to the 1, and then square that side? So here x would still equal 9 if you did it that way. Okay, so last question in the series. Here we've got some pretty crazy terms here. We've got log base 3 of z, log base 2z of x, log base z of 2z, all equaling log base r of r cubed. So the first thing I notice here is all the bases are messed up, so it's sort of guiding me a little bit here, thinking probably change of base might be useful. And once again, you can use any base you want. I might choose base 10 here. Sometimes it's better to choose base 2 or base 3 if you see some common bases there. But I'm just going to go to base 10 and see what pops out here. So for our first expression, this would be log of z over top of log of 3. And we're multiplying that by log of x over log of 2z, or 2z, depends where you come from, and log of 2z all over log of z. I like to keep it all mixed up for everybody. And what's interesting on the right side here, I'm just going to scroll to the top here. Where are we here? Where are we here? If you have log base b of b, then that would have to equal 1. So here, down here, we've got log base r of r to the 3. So this really is 3 log base r of r. So log base r of r would be 1. So really this side would equal 3 here. Okay, so I can see lots of canceling here. So I'm going to get out my trusty red pen and cancel some stuff here. So I got log of z, that can cancel with log of z. I got log 2z, that should cancel. And then I'm finally left with a much smaller expression of log of x all over log of 3 is equal to 3. So a couple ways to go here. One would be to cross multiply, I guess. You could say, well, this would be log of x equaling 3 log of 3. And then I could use my power law here. So log of x would equal log of 3 all cubed, which is 27. So just drop the logs, x is 27. You could also maybe at this stage here change a base law here. So log base 3 of x is equal to 3, and then convert to exponential. So 3 to the 3 is equal to x. So once again, x equals 27. So there's many ways to go on these questions, not just like one way to do it. So I hope that helps a little bit. I've included some questions at the bottom here, and I'll scan a page from your book that you can work on. Wow, lots of emails I'm getting. Anyway, I feel so popular now. Anyway, so I will stop there, and good luck with your studies.